So hello, everybody. Thank you for attending today's webinar presented by Javier Campos on practical use cases of artificial intelligence in finance. Javier Campos, who we remind you, works at Experian as head of data labs for the UK, Ireland, and EMEA divisions. We would also like to thank him for his presence and for accepting to share his knowledge with as many people as possible. During this webinar, you will have the opportunity to ask your questions either in writing in the chat room or by activating your microphone at the very end of the presentation when I will announce the Q&A time. This event is finally expected to last 1 hour. Throughout the presentation, please be careful to mute your microphones and not disturb the speaker. Behavior that interferes with the smooth running of the webinar will result in exclusion from the event. Now that everything has been said, I'll leave the floor to you, Javier, and good webinar to all.
Thank you very much, and good afternoon, everyone. As the introduction, my name is Javier Campos. I'm the head of the data labs for Experian UK and EMEA. I'll introduce very briefly what Experian is, so you understand what we do and why we have this all this experience. Then I will go into definition of artificial intelligence, why it's actually very important, and you will see a couple of very important points. Then I will continue to just focus on a couple of use cases we've been working. So the data labs in Experian, they've been running for 11 years. They were launched back in 2010. So they many projects we have done, but just gonna focus on 2 or 3 projects, and at the end I will try to leave about 10 minutes or so for questions in case someone wants to ask. I'm sure there will be a lot of questions. I also included a couple of slides about going into a career in artificial intelligence for those that might be interested. Okay, so I'll start going very quickly. So Experian, as I said, some of you might or might not be familiar depending on the country where we are, but effectively we are a data company. So we help both companies and consumers to make financial decisions about a number of decisions by providing data. And as you can see, depending on the country that you live, you will see us in all this space. So we of the most countries we have, we do what is called the Bureau of Credit, which is a register of every consumer in a given country. For example, the UK, Spain, the US, we actually hold a record of every consumer, the credit score. So the way we do that is we receive information from all the banks in the country quite regularly every month, and then we compile all the data and then we create a score, which actually tells what is the probability you will pay back if you get a loan. So that the key information. But as you can see, we also have quite a lot of provide data and software to companies to do insurance, in online shopping. We also have a lot of fraud and identity services. You will see some of the project we've done. In some countries as well, we have the vehicle, so we can check that if you're gonna buy a car in the UK, we can tell you, if that car has been in accidents, whether it's genuine or not. So, finally, in countries like the US, we do have a division in health as well, which is quite interesting. Well, we are, as previously said, in about 45 countries, nearly 18,000 employees, and you can actually see some of the numbers there in terms of revenues, country, and so on. So going into the actual data labs, okay, that's Experian, is a financial company, provides financial data to do a number of services, but what is actually the data labs within the company? Well, we are a bit like the R&D part of Experian, and we have 4 hubs, the one in London, which is the one I manage, that we cover the UK and EMEA, but then we also have another one in San Diego to cover the US, in Sao Paulo for Latin America, in Singapore for APAC. And our job is really to create a new generation of product. So we do have really highly skilled teams of R&D, data scientists, machine learning engineers, and product managers, and our job is constantly be scanning the market, scanning the technologies, and coming up with potential new products that eventually all the company will use. That's why AI is actually on our case. The one thing here to emphasize is, of course, we do artificial intelligence, but we're not just AI. We pretty much look at every single new technology that come up. For example, and it's not in this presentation, we're looking emerging technology like quantum computing, which we think is actually going to go into full production much sooner than we thought, within the next couple of years. A few years ago, I would have not said this. It's advanced quite a lot, very surprisingly. So quantum computing, cryptography, for example, we're doing quite a lot of in Web3 in terms of the sort of crypto, decentralized finance. So our job is just to look at everything that is coming out from technology. We also look at the metaverse, for example, what could be the implications, see how we can see the new technology coming up to solve business problem and then apply it. That's why we do. And of course, AI is a big thing of what we do. The one thing to say is we do appear in, we have the thought leadership. So if you look at the in Harvard Business Review, we publish quite regularly sort of reports where we take, and for example, what we do. We also appear on television, and you probably see there my face. I did some interviews on ITV and BBC. Those are British channels for those of you living outside. But the BBC is quite famous everywhere. But we did a project which I'm going to talk a little bit about in here, the COVID, and that's when we went onto the BBC in collaboration with the NHS, which is the health service in the UK. And this is the head of the globally, Eric, which appeared on the CNN. So I think that you can see we do get a lot of coverage from the media because we do a lot of our projects get quite a lot of high impact. And this is, we've been appear in this book, which is being written by an expert, nothing to do with Experian and innovation. It talks about the usual suspect, Google. We Experian have a chapter because of the data labs. So going now into what we hear, the first question is, some of you might have a lot of this background. So I will go fairly quickly, and then at the end I'll go into some of the machine. But I think there is a lot of confusion about what is AI, what is ML. Is people say it's different. I think it's one of those things. It's quite difficult to define actually because and it's not very clear. People confuse. For example, when people talk about AI, sometimes they are talking about narrow AI. And sometimes they're talking about AGI, which is artificial generic intelligence, which is a more generic one. But basically, AI, the definition, and if you look at the Oxford Dictionary, is anything that can perform tasks that require human level intelligence. That system can be thought of artificial intelligence. As I said, most of when people said about AI, is mostly at the moment is narrow AI, which they can do a task, a very specific task. They don't do a more, at the moment we don't generalize very well, and I'll talk a little bit about at the end on the myths. The important also the things to understand is how sort of ML is different from the traditional system. When you look at all of the system or the vast majority of software systems today in every industry, not just in finance, but pretty much everywhere, they're all made in software, and the software is being built, getting the requirements, and those requirements are specific rules. A business analyst have gone, what the software exactly perform. If this happened, then something has happened. So these rules have been coded by a human. So when you use machine learning, that's actually, you don't really tell the machine the rules. what you do is you come up and you say, this is your objective function, something you have to optimize, and then the machine gets the data and it takes decisions to maximize or what, minimize, maximize, whatever, depending. But basically, you tell it, this is your objective function, and then the machine change and makes the rules according to comply with the objective function that you program. And that's a quite a subtle but very big difference, which means, and that's what it called machine learning, because it can actually learn from the data. When it sees the data, it will take it and learn depending on the algorithms. And again, we can talk a little bit about them later on. But I think that the key message here is, an easy way to explain what is traditional software, mostly rule-based algorithm based on machine learning. The rules are made explicit by a human on the software. Somebody has to do them, and the other thing is, when there is a new situation on the rules, the program fails because it hasn't seen it before. Versus machine learning, you don't program every single situation. You just program an objective function, and the objective function is able to, in new situations, make the right call because it's been asked to, depending on how well you do this objective function, then you can do much better or worse. So why AI is important? And people saying is that, another sort of technology, what's the name, hype. As you know, if you know, in technology, every now and then there is a new wave of new developments. There was the internet, there was the mobile. There is a lot of these technologies, wave of technologies, and Gartner and the analysts talk about, and they have this sort of curve of the technologies coming in and out. Is AI another one like that, or is something quite different? Well, I think the AI, and this is why it's very, very different from just another technology, because it's what we call a foundational technology. Why? Well, similar to electricity, and electricity, people don't think about it, but it really changed society at the beginning of the century. Why? Because before electricity, if you wanted power, you have to go to where the power was done, which was in a large factory. And those factories, by the way, they were also close to where the raw material is, the mines. So if you look at even in the UK, in Britain, where the Industrial Revolution was born, most of the factories were really, really close to where the carbon was, the coal was. That's why, and then society sort of organized around that. What happened is once electricity appears, that changed, because all of a sudden you can decentralize the power. You can send power away. And that completely changed the makeup of the towns. And all of a sudden you could actually have towns that they were separated from the mines, you could then send, and that, this sort of subtlety becomes to a completely chain of society, how the people were arranged, new cities, towns, and villages. So similarly, AI is gonna have a massive change in society as well. Why? Because with AI, what you're doing is you are again decentralizing, but now what you're decentralizing is the human level decisions. At the moment today in our society, a lot of processes are around, at some point a human have to make a decision. So the sort of the software, the companies, the processes, they all run there. Once that decision, human decision, you can actually decentralize to the edge, then that's going to change a lot. It's going to change a lot of our society, how we organize jobs. Some of the jobs today, some of the jobs we know today, they might not be tomorrow. The ones we know today, they will be changed. That's why, so the key message in this slide is AI will change the way we work, because it is able to distribute that human level decision to the edge where the consumer is. So, if you are on a phone, on a website, today you get just the same. Everybody's treated the same with some rules that someone has done. In the future, it will feel like you are actually with your own personal assistant, or if you are doing banking, your own personal banker, because it will just look into what you have and it will make a decision. So that's why the AI is a big deal. The other thing is, well, AI is it's magic. Why does it work? Well, the way it works, and this is we're still investigating, by the way, because it's not fully known. But I think that the main thing is what AI does is exploits the symmetries that are on the data sets. So if you, which is, there is a really nice analogy with physics for those of you that actually study. If you think about physics, is actually quite interesting. Is amazing, to be honest, that a very few formulas in physics can explain pretty much all physical processes. And the reason why that happens is because nature has a lot of symmetry. The reason why the electromagnetic rules were that way, there is a lot of symmetry. So actually, and there is a very nice paper which does this comparison. When you look about machine learning, it's the same thing. Machine learning is able to exploit those symmetries there. So if you look at, for example, a deep learning system that is classifying, is doing the different images, classifying images between cat and dog, where actually when you look at what the system is doing, the neural network is actually separating looking at the symmetries that are and exploiting those symmetries to be able to make a decision. Um, so yeah, so I think again the key message here is AI works because of the symmetries on the data. It's not magic, and it works very well, and it works better than the rule base, because it can, when you have, as I said, the objective function, it can make good decisions when it's unseen data. So now going into finance and some of the project we're doing. So in finance, when you look at what I said, AI can, well, the first thing I will say is AI can actually change pretty much most industries. The more you probably see, AI needs data. So you need to have data. And the other thing is sort of exploit the symmetries in the data when they are, especially, so whenever we have data from humans, we actually, believe it or not, we are quite behavioral, meaning we tend to behave the same way all over and over. So that's why any data that is capturing this behavior, there will be a symmetry, and the symmetry means that humans do things. We all do things in a similar way. We all have, of course, everyone has their own personality. This is the sort of behavioral science. Of course, everyone has their own personality, but actually, when you look at within your own personality, you behave certain ways. You wake up, you do things, and that's the signal that the AI pick to really be able to predict how each human will do different. But they can be predicted because on that sort of behavioral repetition that humans we do. So basically anything that has data that is coming from humans, you could, AI can apply. So some of the key use cases for finance, any process automation. So for example, if you have a bank, the process at the moment when you have to underwrite a mortgage, at the moment is a process which is lengthy because you have to go a lot of paperwork, documentation that has to be sent to a bank. In a bank, which there is a massive queue, an underwriter have to review all the applications, look at all the documents, make a decision. This could take weeks and weeks. It's very stressful for the consumer. That can all be automated to a lot of degree. So AI could do that. The other one, of course, is security. At the moment, the detecting when there are, for example, if you look at the banks, and this is why people are scam, especially vulnerable people. So, for example, some elderly people are very vulnerable to being scammed by people calling them, pretending to be from the tax or the police, or, and the police, please send me that money or whatever. If you think about it, you could actually, and there are already some tests, you can have a system monitoring the accounts, and if there is a unusual behavior, you can actually contact there. Like, for example, if I see you try to send money to the police, I said, well, whatever is at the police, or you put something there, you could say, look, this is a bit unusual. let's call one of our people, because I don't think that's actually the real police. The real police wouldn't never able to tell you that. So the security aspect is also very important. That's what the process automation is underwriting and credit scoring. Again, at the moment, sometimes these things have to be manually. You could automate all of these. The other area, which the algorithmic trading, today in the stock market, there is quite a lot of AI, and you probably heard something called a market flash crash, which is when all of a sudden the market sort of go down very quickly. That happened a few times in the early 2000. People didn't know until when the FCA, the FT, what's the name of the organization, the SEC, the organization that sort of is in charge of overseeing the markets in the US. They actually find out that the whole crash, and that happened. I think the first one happened in the 90s. So the first went down without anyone knowing what's going on whatsoever. I think it went down probably 15% within seconds. And what happened is they have all these high trading algorithms, which these algorithms were using AI, and they were the way they were making money, they were predicting doing micro buys very quickly. So buy, sell. If you think about it mathematically, they were predicting where the share price was going to go up or down. And if they could predict it more than 50%, which actually that's random, you could make a lot of money because you're doing a lot of this. That's what is called high frequency trading. The problem with that is if there is only one of those in the market, they will make a lot of money. Nothing happen. But when you have all the systems that are trading shares are doing this, what happens is, if for whatever reason, which is what happened in a flash crash, if one starts selling, they all start selling, and before you know, you just drop like 10 or I think the first one, it was quite famous. It's like 10-15%. So algorithmic trading, there's already a lot of going on, a lot more coming there, a lot of future. And then, of course, the robot advisory. So again, if you go to a bank, imagine having a personal advisor looking at you. You go to a bank and they give you generic advice, or in the website here, they will tell you exactly, what you want for them. So these are the typical use cases, many, the many ones. These are some of the ideas we're doing in our lab. So we have categorization engines. We want to talk a little bit about that. We have fraud modules. We have credit scores, and this is the ideation. This is the things we're looking. We're looking synthetic data, climate change. This is how to calculate the carbon footprint, just looking at your data. Things to do anti-money laundering as well. You can calculate, is that person that is trying to open a bank account, is that going to do money laundering or not? You can do that. So you will see there quite a lot of different projects. They're all in the same use cases. So the couple of things there to say, because AI, you probably see there is a lot of potential, and you will say, oh, hold on, this is so amazing. Why we don't have AI everywhere? And the reality is, and this slide is, even when it's from 2017, is actually the same. The situation hasn't changed much. The only very few models made it all the way to production. So AI is quite hard to do. It's very powerful, but hard to do. Why is that? Well, when you look at there, and the first top of the slide, these actually come from a McKinsey report. To do AI well, you have to really understand these 5 things. And when these things are not understood, then the project will not work. It might work on the lab when you have a model which in perfect conditions work, but when you put it in the real world with real data, it just doesn't fly. So, these 5 points, which are having the right use case, and you will hear me a lot how to do properly. And this, believe it or not, many people still get it wrong. I've seen people starting this the other way around. They say, oh, well, I have what data, first to start AI, I'm going to train all my data systems and clean all the data. That, for example, doesn't make any sense. You can't just, data on its own is not really nothing. You have to really understand what the use case is. And then once you really understand what's the problem, what data do you need? Which in some cases you might need another data that you don't have. And in some cases, you might need, okay, now I need that data and I need to clean it in this way. What it doesn't make sense is to have data on its own, just generic, and you still see big companies doing things the other way around, and they all making large, massive programs when they spend a lot of money and a lot of time on doing, like lake systems and things like that. That's not the best way to do AI. Then use the right techniques and tool again. Here, the one mistake I see doing many organizations is to try AI, treat AI as if it was a software program. So you have the model, you put it, you deploy it to production, and you forget about it. You leave it there or as an API. That is a big mistake. It's not quite the same. You need, but I can talk about later on. You need to do it. And the other one is the organization and culture. So many companies, people are not familiar with AI, so they're very afraid of trying it, and they don't do it. And then the other thing is to have the right teams. Do we have the right data science teams and so on. So I think these things are important. It can be done, and when it's done, is bring you a lot of value. And if you look at the big technology companies, the Amazon, the Google, all these guys, we in Experian, we also have quite a few products there in AI in production and getting a lot of value. But many organizations, even today, they hardly use AI. The other thing, for example, which is another, this is true with the current generation of AI, which is a little dirty secret of AI, which it needs a lot of humans on the back. If you look at this Alexa, for example, I don't know if you realize, but Alexa, the reason why it's so good, because when it's talking to you, when it doesn't really understand, Alexa communicate to the Amazon servers, and eventually some of your conversation might go to a human, so the human can label. And labeling meaning, and this is the reason why one of the techniques in AI is NLP. And on NLP, you have to label, for example, a sentence, what is an intent. And an intent is what is that sentence mean. So when you do in NLP, or in this case, voice recognitions, the first one is a speech to text, which is how do I recognize what the person said into text. That actually for a single person in English is okay. There are libraries that they work quite well, but if you look other languages, or when you have a lot of noise or conversations, or it can become quite difficult for a machine to understand who said what and where. But still, it works relatively well. So effectively, if I say I want to go to Paris, so and a speech to text will generate a file with that sentence, I want to go to Paris. Then you need to pass it to another part of the system, which is to what is the intent of that, and that's the one it translates the meaning of that sentence. In this case, this person wants to book a flight to Paris. So if you're in a website for Expedia or whatever for flights, then that's fine. So this, when you train the system, a human has to train it, and then when you end up with a lot of these sentences, what they call utterances, and the intents, which is being the labels, and then that's how you can train. So Alexa, that's the way it works. So effectively, Alexa gets so efficient because you have these call centers, which are not call centers. They are these places in countries of low cost, like Philippines, India, and so on. And you have hundreds of people listening to the messages, transcribing and putting what do they mean. And then that is fed into the machine, and then the machine gets better and better and better. You only send there the interesting one, but this is something to bear in mind. So the other thing in the future of AI, and I'm going to touch briefly, one of the things also about AI, which it's not a black box, but we need to start talking about the how this AI was produced. So one of the things we've been talking for some time, they're saying that food have a label. If you go to a supermarket, you know exactly what is in a can. We should be able to do at some point for every algorithm, you should have like some sort of like a label telling you, okay, this data set is that. Have you checked that the data set doesn't discriminate? Do you know who the accountability, who actually, if something goes wrong with the algorithms, who is accountable for there? Have you tried the transparency, what data is used, the customer, and so on. So this will come, and at the moment AI is quite starting, but eventually in the future it will come there. So now going deep into a few examples, and this is now part of the output of my lab over the last year or so. So this project it was quite actually interesting. We did it when COVID happened. We partnered with one of the NHS trusts in Nottingham, one in particular. And basically, if you remember at the beginning of the pandemic, and it still is happening, by the way, there was a lot of mess with what data, what isn't, the model, what is predicting. The models are still they're not very good predicting. And in the UK, the first models were based on infections, and they were giving really weird scenarios, which they weren't really sure whether they were true or not. So we actually work with the NHS, and we develop at the level. So rather than having a national level saying, nationally the R is 1, and we work with a hospital. Why hospitals need to know that in advance? Because they need to know. So for example, if the R, you probably are familiar now with these numbers because of the news, but the R naught or R0 call is the ratio of where the disease is spread. And it's basically if one person have in this case, COVID, or this applies to all infectious diseases. So if I have COVID, how many people do I pass it? So if that number is bigger than 1, it means the disease is spreading, and technically even exponentially, because if I pass it to 2 people, then those 2 people pass it to then 4, those 4 to 8, and that number very quickly. And this is why humans, we don't understand very well exponentially. That's why a few in an exponential model, a few days or week can make a massive difference. So these models were not very good. So bottom line, we work with them 3 months, and we manage. And sorry, the hospital need to know about the R, because they need to calculate what's going to be the demand in 2 or 3 weeks ahead. Why? Because they need to understand how many nurses I have to put in reception, how many doctors I need to be in rota, how many ventilators I need, how many oxygen, which was also actually a big problem in the UK. It wasn't on the news, but it was a big problem. So all these things you need to know. So you need a model that advanced. So eventually we work with the NHS Trust, and we developed this using Bayesian hierarchical model, which is quite an advanced algorithm, which will allow us. And I think here the main innovation was to use, such as the artificial intelligence, using. You will see a lot of artificial intelligence algorithms using Bayesian type approaches, which a Bayesian type, you always use priors to sort of understand what is the probability. In a normal frequencies sort of algorithms, you always calculate the probability of an event without taking into account what has happened before, versus in a Bayesian model, you always look at what are the prior, and then taking into account the prior, what I can do. So they're very powerful method, and they use in some of the most advanced AI models. So here the important thing is, as well as the method, which was quite more advanced than the traditional, if you look at the classical infection models, they're a second order equation. They're exponential, but they're very, very simplistic. That was quite a more complex, taking ages into account. And I think the other big innovation here is the data sets. Rather than we find out very quickly that the reported infections were close to useless. Why? Because the reported infections depend on how much testing you're doing, and you keep changing that all the time. So because you change it, and if you don't test, you don't see. If you might be testing a lot, so it is actually useless. What we found, better proxies for how the disease was impacting, and we did a lot of modeling with historical data, is the numbers, the calls to a number in the UK, 111, which is like and also the mobility. The data Google and Apple, they released during COVID, they're still doing it, by the way, the mobility, the average mobility. So we know there is a massive correlation of how the disease is spreading versus how much people is moving. I mean, it makes sense. But by doing the mobility and the 111 calls, we could predict fairly accurate what the R was going to be, much better than the government looking at the infections, which not surprisingly, they made quite a few mistakes. And then the other thing we did is the hotspot risk map. So that was, during the whole pandemic, Nottingham was one of the, I think they never experienced any problems with the planning during COVID, which a lot of hospitals in the UK they did because they didn't have a good planning and they either ran out of doctors or oxygen. Nottingham, thanks to our model, could do a very good job. So that's one thing. Going into now finance, then here we just launched a product in the UK. So in the UK, if you live there, you can increase your credit score, and you have to go with an app. You share your. There is something called open banking in Europe. In France, it's called PSD2, which is the same concept. You can share your bank account with apps and do certain things. But the concept here is we can categorize the. You expose your data, then we categorize automatically, and this uses machine learning, NLP. So you can see here how this works. You do cut the full transaction of your open banking. You cut it in tokens, engrams technically, and then you do a bit of supervised and unsupervised, and then eventually you find out, okay, that in this case, this transaction is betting. Why is important to categorize this? Because then when you categorize, so the first thing is automatically and real time, you categorize all your transactions, and 2 years is about 2,000 transactions. And then on top of that, you create a model to then calculate the credit score with this information, which you don't have on the normal credit score. And then you see how the system, the way it works. I see if I can boost your score or not. If I cannot boost, I don't do it. But if I can, I will boost a few points. So we launched this in the UK and also in the US, very, very successful. It has, and actually it's a big thing because if you increase your credit score, means A, you can get more loans or credit cards than before you couldn't, and B, even the ones you can, you get them with a cheaper interest rate. So it's good for the consumer. It's also good for the bank because it's less risk, so they can afford to do it. And the way to, here the trick is you're using AI and the data. So in terms of now looking at some of the data, and again, getting a bit now technical for those of you that are more interested of some of the Gini. So if you look at a traditional, this is a model to calculate the probability of default, in 1 year. It's called, that's what a credit score or scorecard is. Then you have a single bureau and dual bureau. In the UK, there are a few bureaus. The more data you use, you get the more benefit, although it's expensive, so you need to do the business case. But anyway, if you do the traditional logistical regression with a single bureau, you have this sort of Gini. Compare using machine learning, you do get a much more increase, and I will explain how this come. So you actually get the Gini uplift of 8 Gini point uplift, and more importantly, 30. Well, it's also linked. You get also a bad rate reduction compared to traditional models. And this is how, part of the way we did the project. So we take some of the bank applications, we use the dual bureau, which is all our credit score data, and then we'll do the preprocessing, pass it to the machine learning, the calibration, and then we created these models that in this case, this bank put it into production there. The one thing we do is every time you do a new scorecard, you have to do what is called swap set, which the concept is, okay, if my old model have, and you do the swap set across the sort of close to the cutoff point, you say, okay, what percentage of good and bad this, when you create a new model, how will then impact these things with the old model behave like that? The old model have this accuracy, have these mistakes, the new one with us. So effectively what you found is you can, you can massively reduce the bad rate from the original model to the new one, and that's by nearly 36%, which is a lot, by the way. When you think about a bank, some of the, if this is a credit risk for a loan, and there's a big ban and the portfolio, it's called the book, is 50 million, reducing the bad rate by 36%, that's a lot of money. That's and it's the same data, it's just a better technique. The other thing which we actually did, we as well as, okay, if we now have a machine learning model compared to the traditional one, but it's actually, is the new model discriminating more than, and when we did the, when you check in for fairness, you have to check first the metrics, and we don't have time to go into the details. I mean, the fairness on AI is a fascinating topic. Really, it could be another 2 hours talking about that. And we actually developed my lab a product, and this is why we did it. So then you have to get a attribute, which this is the protected attribute. What you want to make sure you don't discriminate. And here we put gender, age, sex, nationality, sexual orientation, blah, blah. You can put whatever sensitive attribute. And then what you do is, okay, if I have, and this is how the fairness tests work. So imagine you're going to check for nationality. So what you say is, look, if in the wider population you have all these people with these nationalities, my model should have similar ratios. So if there are, I don't know, I'm going to make that up, 5% from foreign origin versus 10% or whatever it is these days in every country, the model should do the same. If the overall population have certain distribution, but your credit score, let's say, doesn't give any credit to the foreign people, say, well, there is a problem there. Your model somehow is discriminating. That doesn't mean, by the way, there is a problem. You need to understand why the model is doing that. If the model is doing that based on income and on then that's something you can justify to the regulator. But if it's doing that using things like, for example, postcode or using data that is not really relevant to your finance, then you can be in trouble. That's why you need to check each of the attributes and each of the metrics. As I said, the metrics, this is for hours. There are many different types there. So the other thing, and this is the, why machine learning? Well, la heuristic regression is literally, this is a simplified two variables, but as you know, a normal credit score have 100 of these. So to visualize that, you have to have a multi-dimension with 100 dimensions. We're not going to do that because humans, we have trouble to see more than 3 dimensions, but in 2, you can get the idea. So basically, a logistical regression is a line. In 2 dimensions will be a plane. In 3, 4, 5, it's a multi, but it's just one line, versus the machine learning model allows to be much more precise. That's why you can actually get that. And the machine learning model actually does better to the other thing that's very good is for the new customers. So this is how the machine learning works by, not being, it's not linear. So it allows to match better the data set. And the other thing is for new customers, it works better. So that's the first, we talk about the use cases. So we talk about a credit risk using machine learning model, how much better from the logistical regression. Another use case in this case is for financial, for fraud, anomaly detection. So this is, and probably you have experienced this at some point. You have a credit card, you travel. And in some cases, if you go, you just land, let's say you're based in France, you go for holiday in Spain, you just land in Spain, you want to go to a shop, you try to use your credit card and you deny. Sometimes happens, sometimes not, and say, what's going on? Well, the problem is the traditional systems in fraud, they basically call rule-based systems. You know what I said before. So in fraud, in this case, traditionally is a combination of one of the major rules for fraud is proximity. So effectively, if your credit card is registered in France in an address, the closer you are to that address in Nice, the less probability of fraud. There are more rules, but that's the first one. So so what happens is and this is why suggestion, if you travel to another country and you don't use the credit card in the airport or when you go there, if the system goes from seeing the car in Nice, all of a sudden it sees it in Malaga, depending on what it is, it might actually reject it. And there are some rules, and if actually I can tell you, if it's a big amount, probably there. So what we did is, this is not right. We can do it better using AI. And in AI, we use neural embeddings. And I think the neural embeddings, and I'm gonna Well, I think these slides can be distributed, but conscious of the time. So the way it works, you convert your input space, which in this case is the transaction. If you think about it, you're getting a credit card. Oh, is that fraud or not? So you need to see, okay, what is the amount? What is the location? Or what is the merchant as well? You check. Um, in the next one. So you check these things. When the time, the online, how much, and the merchants. Yeah. So normal rules, as I said, and sometimes they fail. What we did is don't forget about the rules. Let's use all a combination of that. And then what we did is we created these embeddings so we can do a electronic signature of what you like to buy. So we do the combination of all those. So effectively, if you like to buy a coffee every morning in Nice, when you go on holidays, if you do the same, this system will not reject your car because it knows, look, that's consistent with your behavior. You like to buy, the frequency, you every morning you get €3 on a Starbucks or whatever, that's fine. Whether it's €3, or even if you go to the US and you spend $4, is the same sort of thing is okay. And using this thing, which unfortunately I don't have time to go through all the details of the model, but you can actually see with just 20% of fraud. So that system have a lot of advantages reducing the false negative. False negative is exactly what I said. If you are genuine, your credit card, go on holidays and you decline, but it's your credit card, you are very annoyed because you cannot use it. That's a false positive. With the rules, it's quite high. Using machine learning, and in this case, neural network and embeddings, you can really reduce that quite a lot. So the last few, I just want to spend 5 minutes, what are the different ways to get AI? I had a slide about the general trends on AI, some of the myths, and we can talk a little bit, and then I'll leave about 10 minutes for question. So, actually, probably you already working on a postdoc, or you working on a BEAS, or you already done your degree. But actually, the one thing, and I put this slide because people get sometimes very, they think, oh, I have to, unless I've done computer science, I cannot do. Actually, that's not the case. And a lot of people I hire have a lot of these different backgrounds. The other interesting thing is there are two things here new, which you might or might not surprise you. Law and philosophy, we want to see people coming into the field because ethics is going to be a big area, and the same with biomedics, bioinformatics. Then, if you want to get into as a practitioner into AI, so you can actually do to an apply AI. So for example, my job is to take AI and apply it in financial services, but you can go to any company. You could also look at the research path, but that might, for that you might have to get a PhD and get into a university, and that's fundamental research on AI. Or another way to really get very involved is to get a startup, either your own one or get into one. You will see what I said at the beginning. This is some of the AI jobs. Some of those are already today. Some of them are going to be in the future. So they're going to be, for example, AI forensics will become quite big, by the way, as more and more AI start doing it. Machines behave different than us. You're going to need experts doing that. Chief ethics officer as well, chief ethics officer. The more and more AI you have, you're going to have to start thinking about what are the implications from the ethical point of view, what I want to do, what I don't. So you will see some of these, some of these jobs are today, researcher, sort of data scientist, DevOps, AI, and so on. Some others might come new, cybersecurity as well, very big. But the point is that there's quite a few jobs coming. So in terms of the long terms versus mid fast, and I will consider of them very, very quickly. So you will see here, for example, the myth, and here there are two myths about what is the potential of AI. Some people are panicking, saying tomorrow is going to happen. Some people are saying it's impossible. Those are the two myths. The reality is we don't know. The experts, if you ask me, I don't think, I think it should be possible, but I don't think it's going to happen tomorrow. But as I said, the experts, and you should know that the experts disagree. The other myth is, oh, well, only the really people that they don't like technology worry about AI. The fact is, and I'm me including, actually that's not the case. AI, and I talk a little bit about and this is a strong AI, which, as I said, it's not going to happen tomorrow, but when it happens, we really need to worry. this is a technology that has the potential to destroy humanity. I'm being a bit alarmistic, but the point is, not every technology we do can any technology, and there are a lot of books about the risk to humanity, including an asterisk, and you probably see the Netflix move, but also any technology that can replicate themselves is a danger for us, and AI could at some point think about that and replicate and be a problem. I mean, AI on its own is not a problem, but accessing resources in the real world, it is a problem. Now, the other myth, which is the Terminator and the Hollywood movies, the problem is AI, like the metrics, all of a sudden the machines are going to turn, we want to kill the human and that. Actually, that's not the risk, but the actual worry is misalignment. Remember that AI, you have to do objective function. You have to tell that objective function is really, really hard. And anyone that has put objective to a team, you will know how difficult it is to put objective to humans because they can be contradictors. The same will be with the machine. If we're not careful and we give the machine the wrong objective, it might be detrimental. So for example, imagine you create an artificial intelligence system and say, look, I want you to make sure just fix climate change. If you say just like that, the machine might analyze all the data and say, you know what, the problem is humans. I kill all the humans. Thank you very much. I'll solve your problem. I fix climate change. Unfortunately, nobody told the machine, well, actually, that, and oversimplifying, but this is the risk is misalignment. Is not the machine, because the problem is that's when we humanize. The machine will not hate us. To do that, you have to get emotions there, but emotions is not the same as intelligence. Then the other fact, myth, the robots are the concern, the Terminator. Actually, no. The fact is you don't need a body. You just need a program that escaped to the internet. Another myth that AI can control humans. The fact is, well, we need to be careful. We might be able to do it. The myth is machines can have goals. The fact is actually they do. And by the way, there are already AI using in wars, which is very concerning, and we should do something about this. And this is the final one. The superintelligence is years ago. Well, no, it might take decades, but we should plan ahead. This is coming back to, if you think an unconstrained superintelligence, you need to worry and do something about it. But anyway, so very quick 3 takeaways, and we go to the questions in the last few minutes. The first one: where are we in the AI journey? The good news is we are at the beginning. Those of you might not remember here, but this is what I put the music. It says a tape from the 80s. AI is like that. Even when you think in the news, this is amazing. Oh no, there are so much to do. We haven't fixed. There is so much to do. We have what we call narrow AI. So for some things we do very, very well. In deep learning, image recognition, we do very, very well. Playing chess or Go, fine. But there are, our AI doesn't generalize at all. So let alone the self-awareness of it. So we still very early days, which is good news if you want to come into the field. The point 2 is AI will change all our jobs. So either whether you go into the field or not, you really need to know about it. And the final one, and this, as I said, the presentation is there. If you really want to start into that, you can, I recommend a few books. This is amazing book. Actually, the diagram with the myth is taken from here, you will see. If you are more technical, this is the best book, but you need some high degree mathematics to get there. And the best thing, like everything, is you learn by doing it. So just go into Kaggle. They have amazing data set and really, really nice things to that. The first one which I recommend is the Titanic tutorial. So Titanic, you might know, but there is a list of all the passengers of the Titanic, including who survived and who didn't. You can actually have fun trying to use AI to predict who was gonna survive or not. Quite interesting, by the way. I will let you to do it if you want to do that. Okay, so I think there's about 7 minutes or so. So we'll open for questions, comments. I know it's probably a lot of content.
Yeah. Okay. First of all, thank you very much, Javier, for the presentation. It was passionating listening to you. So I'm Serge Miranda, in charge of the master degree here, and definitely that was passionating. A lot of questions. Couple of the one, just because you talk about finance, it's not in the order, but you just quote crypto money, metaverse somewhere, but this huge financial dimension built by crypto money and Bitcoin. Do you have any concrete use case in this area of crypto money or this kind of crypto finance? And okay, so and your comments about that, about this, your vision of AI and Bitcoin. For instance, talking about frauds, it could be interesting tomorrow to have kind of fraud detection by people using crypto money, if there are, etc., etc. You could imagine. So, what is your
Yes.
vision?
I mean, it's a good question, but is very big and complex. Absolutely, the way and again, I think this is the whole field is called Web3, which if you think about the reason it's called Web3 is Web 1, 2, and 3, different generations. In Web 1 was at the beginning of the web, everything was centralized in one place. So the content, and you could only consume content. The Web 2, you have two ways and you have the apps. And in Web 3, the ownership goes from the center to that's what is the centralized web. That's what they call it, the Web 3. So massive potential. AI can do a lot of stuff and is already doing. So there's a lot of fintech. So for example, you can use AI on the market to calculate whether, at the moment I will say, and I think the crypto, I will separate the technology, which uses really good like distributed ledger, some sort of symmetry and so on, versus the actual crypto as an asset, which is an investment asset. And if you look at BTC, Bitcoin or Ether, it's got a value that goes up and down. That's another debate whether that make that. But in terms of the use cases for AI, many. So for example, you have fraud, like you can actually, one of the things about Bitcoin is you have to have a wallet ID to be able to transact. That wallet ID is anonymous, which is a problem for the identity, by the way. But eventually, if you can see, you can actually create models that generate what is the probability of this to be fraudulent or not. This is actually quite important. And another area, for example, which I don't know if you probably have heard about, NFTs, non-fungible tokens, there is a lot of fraud. Effectively, the fraud is, and you can do it with the technology. You can create, if you do it well, again, without going into the debate whether it makes sense or not to have a digital something for yourself and pay a lot of money for something that you can get a perfect copy. But anyway, I won't go into that. Let's assume for a minute there. What happened is using protocols, in some cases you can, and there are people already scamming a lot of people, but using AI, you could actually reduce a lot of that. So you can, anything, so for example, to the optimizing the the different transactions and the in fraud reductions, which is going to be quite a lot, to the market as well, to high trading there. So quite a few use cases there in the technology.
Okay, thank you very much. Just another question, also a couple of questions from a technical point of view. You emphasize the fact of explicability for AI, and I think that's a major issue even for researchers today, who are planning today to solutions where you have hybrid AI using machine learning tools with rule-based system and deep learning tools where explicability is missing. And what is your experience concerning this kind of hybrid solutions between deep learning and other machine learning methods?
Yeah, explainability is an issue. It's also a complex one because, by the way, and if you think about this, and some people, they always say, "Oh, it's a black box." Well, it depends on what it is and it isn't. So the first thing I will say, which is a good point, every algorithm have different ways to being explained, and some of the algorithms are relatively easy to explain, especially if you put some of the variables. So the one that is, and that's what in the news, the way, a deep learning system, the way it sort of learns, it can be quite quite obscure, and that can be quite difficult. So there are a few things. It will be quite difficult to explain to a human or to say in a different, in a way that a human would understand, and the reason is because the machine is using other logic that we don't use. So for the right algorithm, you can explain it. Even using deep learnings, there actually can be technique that you can use it. And for example, the example on very quickly on explainability, they programmed this software to detect a wolf from a dog, and they trained it with millions of pictures. It was absolutely 99.9 perfect, perfect. Then someone went to a zoo, took a picture of a wolf, passes to the system, and it failed completely. And then the expert saying, "What's going on? That's cannot happen. That wolf is a very clear wolf with the big there. What's going on?" So what happened is when they look at how they train the machine, they actually realize that all the pictures of the wolves were in nature, and because wolves tend to live in sort of high level in mountains, pretty much everyone have snow. So effectively, what the machine has done, and this is what I said about the opaque. I mean, this took months to figure out what the machine was doing. What the machine is very good to get shortcuts and to really understand what it is. You just put in the label. So the way it works, you say, okay, this is wolf, and you put the word. This is a picture of the wolf. This is a picture of dog, wolf, dog, dog. You fit off these million pictures, and the machine then does the there. So what the machine was doing is it actually learn is much more efficient. As soon as I see a snow, call it wolf, and I make the prediction right. So effectively, if you think about it, the machine wasn't, you can argue, understanding, because humans, we all have a model of the world, and that's how we explain things. The machines don't work like that. I mean, this generation of algorithm. So the point about explainability is absolutely some algorithms are, and this is again is a myth. Some algorithms is zero problem with explainability. They call an XGBoost, like the ones I show. You can do the same explainability for it's a bit more difficult than because the logistical regression is linear. So you can say for this income, I accept or not, which I might make a mistake, by the way. That's the other thing, but it's relatively easy to explain why you are rejecting. On the machine learning, because it's non-linear, sometimes the income is true, but sometimes it's not. So there's a bit more complicated explanation, but you can argue that it works better. And I think that's the so my whole take is this is an area that we are advancing. The other thing which also need to be, and this is an area of research, we also need to be careful, because a lot of the algorithms, but not just AI, even the current statistical algorithms are correlation-based algorithms, which means they're not causal inference algorithms, which means they don't really explain. So the point is, even the current algorithm is not really explaining, and you can see that in entry-level college for education, but not for others. So big topic, even if you use deep learning, it can actually make, and for example, what happened on the deep learning, rather than teaching, let's say, the last problem, like for example, in a credit risk, you will say, give all this data and predict if default or not. Rather than doing this, what you would do is you start predicting individual features, predict the income, predict the expense, and then all these things can be explained, and then you can use deep learning. But use especially deep learning because the reason is the way, I don't have time to explain, but it uses a lot of hidden layers, so it's not obvious to see what is doing. And even the snow example I mentioned, it took months to do it.
Thank you. Two very short questions finally. The first one is, when you're looking at the work, the AI work which is performed in your data lab, concerning the algorithm which exists in the market, there are hundreds of machine learning, etc., and various types of deep learning. Generally speaking, do you use existing algorithms, or do you build new ones and eventually optimize existing ones? What is your production? Is it in producing new algorithm and eventually have patterns on that, or just using and applying what exists?
It's a very, very good question. So we do a bit of both. At the end of the day, if there is something out there, so for example, an SGBoost, we use any of the libraries, we have our favorite one, but why would I do my own SGBoost? I wouldn't. We are an apply lab, not a research. However, if we're doing something that there is not really a good algorithm out there, and when we did the project in fairness, so for fairness, we created our own algorithms. We actually publish papers in arXiv. I can send the links. We are at the moment filing for 3 patents in UA, in Europe, in UK, and US. So these algorithms we completely have, because the problem is unfairness. We started this project 3 years ago. There wasn't anything in there. At the end of the day, the best way to describe, we are here to do a speed to value, to give Experian a competitive advantage on our competitors, and we do that. You have to be fast. Sometimes, well, if it's something that is really new and like, for example, no one has the algorithms on fairness we have yet, it will happen at some point, but that gives us a competitive advantage. But if it's something that like SGBoost, like everybody have one, we just whatever it is quicker, so we'll utilize that.
Okay, thank you very much. And final question, as far as I'm concerned, you quote 5 important elements of successful AI transformation, and since you had end-to-end applications running, where do you say it's eventually the most important step? Are all the steps important? From a technical point of view, for me, use case and source of value, proof of value, etc., is not a huge step, but I would like to know the human factor. The human factor is the most difficult part, for instance, in the organization, in the governance, or in the technical aspect, and what is of prime importance for you to be successful?
Yeah, it's a very good question. So if I have only, you saw there is actually quite a few challenges. People struggle, to have the right tools, the right people, and the approach. But for me, if I have to pick one, is the governance. You need to have, and for that you need to have the right support from the top management. If you're doing this in a company, and some people have described middle management like a permafrost, like it's not just for AI, but for all the antibodies of a company. So middle management is designed to be really risk adverse, and they're not going to try anything. So all these things, there is a lot of value, and they work. But because a lot of the middle management are incentivized, which is a bit, that happens also in public office. In many places, if you do something that is amazing, they might give you a big bonus. Okay, but if you miss something, then you could actually. So if you made a mistake, you could get in problems. So there is a massive imbalance on, if you really do something really bad, you're going to be fired. If you do something amazing, well, you might get a bonus, but it's not there. So because this imbalance, and that's what normally is with the middle management, you always have to have full support from the top, so they can actually really help. And then, technology works, providing you're doing it well. It's just the human element, and how do you overcome this middle management? So for me, the one thing you need to look is the governance, to make sure there is the right accountability. And the other thing with AI is, don't think of AI as a standard software. The return on investment sometimes, actually, unlike normal software you put it at the money you put it, start earning money little by little. AI sometimes is exponential. So it takes a while, because with AI at the beginning, it might not have good data, so it's still not performing well. Some algorithms, but then once it start getting more and more data, it gets more accurate, all of a sudden, then, so the point is the return on investment, and you need to talk to the management. It might be a bit longer originally, so it's a bit of the trade-off. Look, rather than earning little very soon. You might take longer, but then when you do it much better.
Okay, so questions in the by students. And first of all, there is a question, and that's Mishket. We can answer to share the video for watching it later. The videos will be the video is recorded, will be available in the School of Engineering website, along with the other webinars and along with the Datum Academy. So that will be shared, of course. And there is a question, what do you see? It's not mine, so it's Harry's question. What do you see as a future of banking products in terms of AI? What is a revolution we could expect from AI in banking products tomorrow? Beyond fraud, beyond scoring?
But I think you're going to have quite a, if you look at the banks, usually are divided into front office, middle office, and back office. So customers will see there's going to be a lot of interaction, and it's already happening in process on the back office, which means you will see things done quicker. In terms of the customer, probably the best thing you will see and is coming is a robot advisor. So effectively, someone who can really is like you're talking. The problem with if you look at the financial advisors at today, unless you have a net worth of few million, it's not worth it. But they can actually make you money. In the future, these, imagine a robot which is actually looking constantly at your money and is giving you advice all the time. Is, for example, you have a credit card with certain rate, and this technically can happen today. There are reasons why it's going to take a while, but the machine could be looking all the time new offers on credit cards, and if detects there is a new credit card better and it makes the calculation, it might close, you get your old credit card, do that, open on your behalf a new credit card with a new vendor, which because it calculated, it knows you're gonna get granted, so you don't have to even, that will be automatically. So it will create a new credit card, consolidate 2 or 3, close them, and then save you on interest, whatever. You could do the same for investment, you could do the same for pensions. So a personalized, very efficient financial advisor, this will happen. It might take, and as I said, a lot of the technologies are today, but for many reasons, regulatory and everything, there is not quite there. So I think for me, you will have a personalized finance one-to-one, and it will feel like you have your own personal banker with you all the time. Even, and this is another thing that might happen in the future, even before you actually, or where you might do some bad financial decisions in terms of, you could take it to the extreme, but if you look at optimizing a financial life, most people, we don't even think about these things, even in the industry, but people sometimes make bad decisions in terms of rent versus a mortgage. Should I buy this car? If I buy, should I finance or not? What deposit all these things could be done for you, or could actually be the most efficient. And at the moment, there is a lot of inefficiency. So there is a lot of potential there.
Okay, thank you very much. That's fascinating to see how it will happen in the future, to have this kind of online interaction with a robot. Second, another question from Sergio Simonian, a researcher, deep learning researcher at university, working with us, is the fact that it's very close to the previous one. What applications do you see for large language models in finance as part of automatization of bank customer interactions? So for me, you answer that question. Maybe you would like to append something, because the question is, do you see the emergence of language modeling in finance as part of this robot automatization, etc.?
Absolutely. I mean, any robot advisor, you're going to have 3 components. You're going to have the speech to text. So you need to be able, whatever I'm saying, put it on a text file. The second one is analyze the intent, what I'm trying to say. That's what you need NLP. And then finally is what to do about it. That's the other, but that's easier. So the most difficult one is you got your utterance, which is the sentence, whatever you said, how do you interpret it, and then how do you feedback. So absolutely. I think the other thing, by the way, NLP is used. I didn't have time, but another project we did with a bank in Italy, which is fascinating, is we can actually listen to a conversation. So, for example, when you default, let's say you cannot pay a credit card and then you default, and then you go into something called collections, so people want the money back, so they start calling you. And one of the things they need to do is do a repayment plan. And on the repayment plan, it's important to know, are you gonna try to do it or not? So we develop a model using NLP, which listening to a lot of these conversations when the call center called the customer and said, look, are you going to pay or not? Well, it was a long, it have a lot of questions, everything. When we did that using NLP, we could calculate fairly accurate who was lying and who wasn't. And the reason is because, and the way to do this program is you analyze, you listen to the last year, 100,000 conversations. All these people said they were going to pay. These ones didn't. This one did. You get into the machine. You get the target, which is look this. So when you analyze, and this is using big data and NLP, when we analyze all this language, we found certain patterns. It's fascinating. So the people that lied, for example, didn't use third party, sometimes pronoun to refer to you. They were very vague. So there was a lot of signal on the language to estimate this customer is lying. He doesn't want to pay. And why is important? Because if when you're doing, imagine you have a problem, most people, by the way, when they have a problem, they try to repay, and then you should hold because eventually you get the money back. But if you know someone have no intention to pay, what you do is then you send that to another agency and you sell the debt. And then actually you save a lot of money, because otherwise, if I keep calling you, so the way collection works, you own a euro, how many pen, and people only get a fraction of that. But the sooner I know if you're gonna try to repay or not, the sooner I can reduce my cost. So this, there are quite a few. I think I will say a language is quite important because, as I said, on the transactions, on the bank transactions, there is a lot of language and there is a lot of signal, because whenever you go and buy a coffee, believe it or not, on the debit, on the payment transaction, there is the locations, there is the sort of number, there is. So I think NLP has got a big future for fraud models. You can predict who is. The other thing we can do is we can even using language, do a lot of things. One bank, by the way, they challenge us, which is we're still thinking about is a bit too much. I said, look, can you using voice, if you listen to someone, can you actually give a loan just listening to someone? This is again NLP. I give you a think about that. That's a difficult one. Yeah.
Okay, that's very interesting. That's close to the last question I see in the discussion in the chat from Moise. Can we teach AI to detect human feelings or to predict it? So that's exactly your last comment concern this. Globally speaking, sentiment analysis is part of an AI solution somewhere. You just gave a good example with the Bank of Italy, but beyond that, this aspect of detection of human feelings, whether person is cheating, not cheating, comfortable, stress, whatever, is that a function which is of importance in any AI solution?
That is a very, very good question. And here I will say it depends. And so the first one, and this is why concerning, and China is doing things here, which is very, very debatable. So there are two things here. Can I, looking at for example, looking at your language, looking at your behavior, your transactional behavior, looking at that, can I see if you are cheating or yes, in many cases, but that's one thing. Now, can I, for example, which is the big debate, if I look at you, I do face recognition, can I see if you are upset, happy, that, and I'm very categorically, there is absolutely zero serious research that says, when you have that face, you're happy or no. So here there are two problems. Can you, face recognition is very advanced and can do a lot of things. So that's one side of things. So I could see if you are smiling or not. That is possible. But the other thing, which is where there are a couple of fintech in the US and in China that what they're doing is they're looking at your face expression and they are claiming, and if you ask me, that's not true, by the way, and you should go away. Because the science is not there, and why is not there? Because all the expressions in the face is very cultural. So, for example, if you are French or Spanish or English or from any country around the world, every country, the expressions are different. We are all different. So there is, as I said, there is no absolutely, no zero. There are very, very, very few, and it's all very, you wouldn't see a lot of peer reviews. You wouldn't see proper scientific research that can tell, given expressions on the face. Some people say, oh, blah. So therefore, there is, especially in the US, I've seen a lot of fintech that said, I can, for example, for interviewing, I can do a job interview and I can infer the feelings or the abilities of this person. That is actually very wrong, but which is the irony. The AI can actually understand the face recognition and everything, but scientifically, there is no correlation, a universal correlation between our expression in the face and our feelings. That has been shown so many times. So just with the face recognitions, emotions, maybe a bit uncategorically, it's not possible. The science is not there. You might think I'm unhappy or unhappy now. There are some cultures that they are less prone to smile. That doesn't mean they're unhappy. They just don't smile. At the same time, there might be cultures, in the Nordics, sometimes people, they're a bit, you think they are all the time really happy, smiling, and actually half of them are depressed because they don't have sun. So you can't really, as I said, the science is not there. At the same time, when you get a lot of different data points from different places, it is possible to get predict a lot of the human behavior, like, what you're going to do next, whether you're cheating or not. Those things are possible, but it's different from, the face recognition and the feelings.
Okay. As far as I'm concerned, I'm through with the questions I see from the students, from myself. Mishket, since you follow the complete stuff, if you have any extra question, please, I give you back the word and to let everybody knows what happens with the presentation, when it will be online, etc. So Mishket, are you there?
Yes, I'm here. So thank you, everyone. Thank you all for participating in this very, very interesting webinar. Thank you, Javier, for having been kind enough to share with us all your knowledge on artificial intelligence and more specifically in the field of finance. So you will all receive by email the link to the replay of the video tomorrow morning, as well as the presentation in PDF format. And if nobody has no more questions, I wish you a good end of afternoon and a good weekend to all. Goodbye, everybody.
And thank you very much, Javier, for your webinar. And I'm quite sure we'll have a fruitful cooperation in the future.
We'll do. I just post a link, by the way, which talking about the feelings. Don't buy shares in this company. You will lose money.
Okay.
Okay.
Have a nice
you.
weekend
Likewise.
and good luck and take care.
You
Thanks,
too.
Javier.